The first step to performing a combustion analysis is to turn your analyzer on outside in fresh air. This allows the CO sensor to auto zero to the presence of 0 CO outside in fresh air, and it also calibrates your oxygen sensor to the presence of 20.9% O2 outside. So let the analyzer run through its 60-second auto zero cycle till it's complete. Make sure the probe is disconnected, that way you get the maximum amount of fresh air going into the analyzer. And then also make sure that if you left your analyzer in a cold truck overnight, that you let the analyzer warm up and acclimate to a warmer environment. That way you're not going to shock the CO sensor when it's exposed to hot, wet stack gases. That could cause condensation formation on the sensor, which may cause an error on the sensor on the display. So allowing the analyzer to run for maybe about 5 to 10 minutes to dry out the sensor if it does get wet is a way to remedy that. After the auto zero cycle is completed outside in fresh air, in order to maximize the accuracy of the CO and oxygen sensor, the first thing you do is walk into the residential or commercial facility and test for ambient carbon monoxide levels. You want to make sure you're not walking into an unsafe condition. So the ASHRAE standard for the maximum allowable concentration of ambient CO is 9 parts per million over a 24-hour exposure. The other standard is 35 parts per million over an 8-hour period. But in reality, there should be 0 ppm of ambient carbon monoxide present in the ambient air inside a building. So now we'll do the initial setup of the combustion analyzer. Today we are using the Novo analyzer from SEITRON. It's available with or without a built-in printer, as well as a 7-inch touchscreen, as you can see here. So one of the first things that we're going to do is we're going to make our connection to the bottom of the instrument. Now, one of the first things to notice is that the water trap, as well as a filter, is built into the instrument. So you want to make sure that you have a clean and dry filter installed, as well as make sure that there's no condensate still in the water trap before you begin your test. All right. Then what we're going to do is we're going to connect the sampling probe. So we have a single connector with our flue gas, our pressure, as well as our type K thermocouple. So we're going to plug this into the single port here. It's a very easy connection. Now we're ready to go. So one of the next things we're going to do is set our fuel selection. So on the display screen of the analyzer, you go to settings, then you select fuels. And now depending on if we're doing natural gas, oil, or propane, there are various pre-installed fuels that we can select. This selection will then tweak our carbon dioxide as well as our combustion efficiency readings. The other thing is that for high altitude areas of the country, you can also set the altitude settings within the analyzer. That way you have the ability to adjust your readings if you are going to be in a high altitude setting. So now we're going to perform a combustion analysis on an 80% natural gas fired furnace. So one of the nice things about the Novo combustion analyzer and the other SEITRON analyzers is that they always include a cheat sheet, which gives you your typical and optimal combustion results for different types of heating appliances. It also gives you the various measuring points for your combustion, for your draft, etc. That way you know exactly how to get your undiluted flue gas measurement. All right, so for this particular system now, our combustion analysis is taken from the same exact location as our draft measurement. So it's about 1 to 2 feet away from the induced draft motor. So we're going to insert the probe into the flue after having previously drilled that hole, touch the back wall, and then draw it back about halfway. And then you're going to insert the positioning cone like so to plug up that testing port. All right. So now we can see that our flue gas measurements are beginning to change. So our oxygen is dropping down, carbon monoxide and carbon monoxide air free are beginning to increase, as well as our CO2. We also see our combustion efficiency will be hovering around 80% efficiency. All right. So now, if I wanted to save my combustion results, once they are within the range from the cheat sheet, I'm going to hit the snapshot button to freeze my readings, and then I can print out directly to the built-in printer for the Novo analyzer. Now, if you would prefer to generate a digital report, you can download the free SEITRON Smart Analysis mobile app, and then using any Android or iOS device, you can actually generate a QR code based off of that combustion analysis, and then you can scan that QR code and bring the readings back into your device. And then from there, what I can do is I can save this, enter in the customer's data, the equipment details, make, model, serial number, as well as your own information, and then I can email out a PDF or Excel report from the field. Another nice feature of the Novo Combustion Analyzer and the SEITRON Smart Analysis mobile app is the ability to remotely view your readings from your phone or tablet. So anything the analyzer is reading, I can now see live on the display screen of my combustion analyzer. This is particularly nice for larger commercial systems where you might be standing far away from the measuring point making your burner adjustments. So in this case, you don't actually need to have a hose extension. You can simply view your readings in real time from your device, all right? So a few things that I can do now is, number one, I can remotely print directly to the combustion analyzer like so. Or if I want, I also have the ability to save multiple snapshots. So for example, if I'm doing a low fire and high fire test, I can hit snapshot and then add a note associated with that particular snapshot, right? So I can I type in low fire, save, and then I can make as many snapshots as I want, add additional notes, and then I can save my analysis and once again, create a digital report by typing in the customer's information, the equipment details, as well as my own information, and then I can generate a digital report as a PDF or an Excel file. So after we have finished our combustion analysis and we have created documentation of the analysis, what we would do is remove the probe from the stack and set this down because it's likely to be hot. We also want to make sure that we are plugging up this hole for good practice. Now for an 80% plus system, this is actually going to be negatively pressurized. So in reality, the flue gas is actually going to be going up the stack and will not be spilling out of this measuring point. But it's always good practice to plug up the hole with high temperature silicone, for example, as good practice. So once the combustion analysis is over, we're going to leave the analyzer connected to the probe and give it about 1 to 2 minutes to purge, all right? That way, we're allowing our carbon monoxide readings to drop back down to 0. We're letting our oxygen go back up to 20.9%. The reason why we're doing this is we want to make sure that any of that residual carbon monoxide that's present in the analyzer or within the sample line is fully purged. That way, we're going to really extend the lifespan of our CO sensor because when we turn it off, it's not going to still be measuring carbon monoxide that's still present within the instrument. Okay? So then once the readings have gone back to 0 for carbon monoxide and 20.9 for oxygen, you're going to disconnect the probe, and then we're going to open up the water trap and just make sure that we don't have any residual condensate that's present in there. If there is, pop this open and dump out any condensate. You can also check the filter to make sure it hasn't become dirty. If it has, you can also replace that at this point as well. This should also be checked before your next test. So once you've done all of that, finally, you can turn the analyzer off, let it run through its final purge cycle, and then you're good to go to store the analyzer for your next test.